Thin layer chromatography, better known as TLC, is used to identify unknowns, test the purity of the product, and monitor the progression of a reaction. TLC plates consist of silica gel that allows for your sample and absorbent to absorb onto it. When you get your TLC plate, it will look like this. Before obtaining your TLC plate, take precautions and hold the plate by its sides and do not touch the white silica gel. After you obtain your TLC plate, you will need to draw a line 1 centimeter from the bottom. It must be in pencil, because inks from pens will travel up the plate and affect the progress of the reaction. Now, you will cut the sides of the plate to help the solvent line rise evenly. It should look like this. After you cut your TLC plate, obtain a TLC spotter, which are commonly called capillary tubes. Create a space for each one of your samples. For this experiment, we have 2 samples, benzoin and benzyl. To spot your TLC plate, dip your spotter into your sample and place a small spot of your sample onto the corresponding point on your line that you marked above. Let the spot dry and repeat 3 to 4 times for each sample. Make sure that your spots do not overlay and make sure that the capillary tubes are used for their corresponding samples. Do not mix them. Now that we have done the benzyl sample, we will do the benzoin sample. The same procedure follows. After you're done spotting your samples on your TLC plate, it should look like this. Now that you're done with the spotting of your samples on your TLC plate, obtain a glass jar with its lid, as in your lab drawer. Pour a few millimeters of your mobile phase, which in this case is ethyl acetate hexane mixture. Use tweezers to place your TLC plate into the jar. Place the lid on the jar so that the solvent will not evaporate, and let your TLC run until the solvent almost reaches the top of the plate. Make sure that you do not let your line run all the way to the top, because your TLC spots will be at the top of the plate. When the solvent line is near the top, remove the plate with tweezers. Now quickly make the solvent front, the line where your solvent stops, with a pencil. This must be done quickly because the solvent evaporates and the line will disappear. Now that we have run the TLC plate, let's visualize the results. There are 2 ways to visualize the TLC spots: UV light and iodine staining. First, we will observe with UV light. Hold the UV light over the TLC plate. Your spots will appear. Circle the spots under the light, as shown. The retention factor value, or RF value, is the distance the spots moved divided by the distance the solvent moved. First, measure the distance traveled from the initial line you drew to the solvent front. This is the distance the solvent moved. Next, measure the distance traveled by your spots from the initial line you drew to the middle of the spots. This is the distance the spots moved. This is a good picture summarizing how to calculate the RF value. Second, we observe with iodine staining. You will place your TLC plate in the jar of iodine and lightly shake the jar to spread the iodine on your plate. The iodine will stain your plate, causing the spots to appear yellow. Let's try to better understand our results. The silica gel was used as the solid phase. Silica gel is a polar adsorbent that can hydrogen bond. Therefore, if the components of the mixture are polar and can hydrogen bond, they will interact more with the silica gel and thus move less quickly up the TLC plate. Nonpolar compounds will move faster and go further up the TLC plate. The more polar spots travel slower, and the less polar spots travel faster. The spot with the highest RF value is the least polar, and the spot with the lowest RF value is the most polar. In this case, benzyl was more polar than benzoate, and therefore traveled farther.